Hello, and welcome to my talk on tourism motivation. Today, I'm going to adopt a complex adaptive system approach to tourism motivation. My name is Jalayir Khalilzadeh, and I am an assistant professor at East Carolina University. Before I start, I should mention that this is a research in progress, and I'm actively looking for grant opportunities to develop and finalize model. So if you're interested in collaboration or if you know any resources that can help me, please do not hesitate to contact me. Thank you. So I'm going to start with a simple introduction to motivation in tourism and then move on to the conceptualization of the model and demonstrate with a small example and a few concluding remarks. Like any other concepts, precise definition of the motivation seems to be impossible. There are many definitions, but the one I have chosen for the purpose of today's presentation basically consider motivation as the energizing factor of the behavior in pursuit of a goal. It's a fundamental property of all deliberative behaviors. There are two conceptualization of the motivation. One is motivation as reason, and the other one is motivation as force. Also, when talking about motivation, one should consider two major types of A motivation and D motivation, which A motivation basically is the state of inaction, and demotivations are the type of negative forces that we use when it comes to avoidance. 1950s is the time that we can find some trace of motivation studies and starting point for the motivation studies basically. But it wasn't until late 60s and early 70s that motivation studies found their way into tourism literature. 70s is the bedrock of tourism motivation studies. However, most of them empirically found no support. Even the most celebrated push and pull factors, which is still popular, has a lot of issues. 80s and 90s basically is the time for some major adoptions from psychology literature. And then late 90s and afterwards is the time that most of the tourism scholars start using non-native theories such as self-determination expectancy theory in the tourism context. It seems that it's the time for change. If you ask why, well, there are dozens of reasons, but maybe the most important one is most of the existing models and theories fail to explain and or predict irrational consumption behavioral changes, the impact of seemingly non-relevant events on traveler behaviors, such as Gulf War on Japan's tourism, for example, or the connection between motivation and other concepts such as expectation, attitude, value, and actual tourist behavior, and the underlying layers of motivation. With that, we can start defining our model. We are dealing with a graph of G with two sets of vertices and edges. The set of vertices is itself is composed of two sets of disjoint vertices of destinations and reasons. In other words, we are dealing with a bipartite graph of destinations and their respective reasons. The edges are weighted based on the number of times reasons assigned to a destination, and also reasons can signify motivational or favorable reasons for the destinations and demotivational or unfavorable reasons for the destinations. Our destination set is unbounded, and this is because of the very vague and abstract definition of the destination. A country is a destination, as is a city, a state, province, or even a single attraction with some touristic significance. All of them can be considered as destination. For example, on TripAdvisor, we have more than 156,000 destinations listed. The same goes for the reasons. We can argue that there are as many reasons as there are people in the tourist generating region with reasons to visit a destination or avoid one. As a result of these two unbounded sets, we can assume that we are going to deal with a fat tail type of distribution, and most probably it's going to be a power law distribution. Also, we know that destinations can follow preferential attachment principle, as early exposure of the destination to the market can bring a lot of reputation, a larger ego network, and a larger exposure to the market for the destination. The same goes for the node fitness. There are so many examples and evidence of destinations in similar situations with similar policies and practices ending up with different type of positioning and tourism development level. As a result, the same governing mechanisms of scale-free networks can be identified for the tourism motivation network. Now that we have defined the model, we can come up with some measures and indices to conduct the analysis. The simplest one is the degree centrality, which is simply the number of edges connected to a vertex. The second one is the weighted degree centrality, as we are dealing with a weighted network. Also, its normalized degree centrality can be useful to identify the importance of the degree. The next in line is degree probability, which is simply the probability of encountering a specific degree centrality. Also, we can calculate stress centrality or betweenness centrality depending on the type of conceptualization. However, this one is not the main purpose of today's presentation. Entropy is calculated with a weighted degree and its logarithm. Then entropy itself can be used to calculate diversity. Since diversity is a normalized value, we can calculate order by subtracting diversity from 1. Following the logic of the relationship between entropy and diversity, we can use the reverse approach to calculate energy from order. And using an entropy level and energy, we can define the stage of the node. Aggregation stage nodes are the nodes with both entropy and energy increasing. Synergization is the stage that energy is increasing but the entropy is decreasing. Equilibrium is when both of them are decreasing, and dissipation is the time that we see increase in entropy and decrease in energy. Also, we can calculate the organization by subtracting diversity from order. However, diversity in a network for many 1-degree vertices can be undefined. As a result, it's better to use relative organization, which is normalized energy minus normalized entropy. Using relative organization, we can come up with 2 states for every node. Either a self-organization state, which means that the node has higher energy compared to entropy, or it's an emergence state, which nodes has higher entropy compared to energy level. We can calculate the complexity as well by multiplying the diversity of the node to its order and scaling it with the number 4. 2 final measures I have developed for the purpose of this study are utility of the reason and utility of the destination. The utility of the reason is basically following expectancy theory by considering degree probability as the expectancy of the reason, and weighted degree as well as the normalized degree to be considered as the instrumentality of the reason, and finally multiplying it by a dichotomized variable b, which will take the -1 value for the demotivation and the +1 value for motivations. Obviously, we can use the sum of all neighboring reasons for every destination as the utility for each destination in terms of the absolute value of the motivation or demotivation. With that, we can show a simple network which is created by asking 40 individuals in a Middle Eastern country that which destinations they are willing to visit and which destinations they are avoiding, and their reasons for those 2 scenarios. In this case, you can see destination Afghanistan, which is mainly in the realm of demotivation with all those reasons people don't want to visit. And then on the contrary, we have destination France, which is apparently favored by all of the participants in the sample, and they are willing to visit. We have Malaysia, which is a destination that has a combination of demotivation and motivational factors. However, the demotivational aspect is stronger. Here we have US on the opposite side of the story, with some demotivational aspects and a lot of motivational forces attached to it. It's obvious that there are so many shared reasons, but every destination can bring its own new reasons to the network. If we continue building our network, we are going to end up with a network like this. This is a simple toy model of the our study. A small network of size 380 with the order of 121 and assertivity of -0.202, which is an indication of strong, dense relationship between the motivational and motivational side of the story. As expected, the clustering of this network should be 0 as there are 2 disjoint type of vertices. We can calculate the distribution, and as you can see in the histogram and the log-log plot of the tail of the distribution, this is a kind of fat tail distribution, but it's not obvious whether it's log normal distribution or power law distribution. Even it can be exponential distribution. However, we can expect the same type of behavior that we expect from fat tail distributions. That said, the 2000 bootstrap that I ran on the distribution suggests that we are dealing with the power law distribution in all three networks of the entire system, destinations, and reasons. We can map the level of entropy and energy. In this case, you can see the entropy map. The darker yellow colors indicate the higher entropy becomes. It's the same for energy. Darker green colors shows the higher energy level in each node. And if we compare them side by side, you can see that entropy and energy are not mutually exclusive in motivation system. For example, in case of Italy, if you see Italy here, this destination has a high level of energy as well as a high level of entropy. Then you can, for example, see the Sweden down here with a very low level of energy as well as a very low level of entropy. But this is not the whole story, and you can find all other types of destinations in between. In fact, combining these two indices, we can analyze the stage of the node. As you can see, most of the nodes in equilibrium stage reside on the peripheral area of the system, whereas the aggregation nodes are in the core area of the network where all the action is. We have very few dissipation and synergization type of nodes in stage. However, since the data collection was not longitudinal, I only used the relative values in this case. So in future studies, this should be considered to be a longitudinal information if we consider the system over the time. From node state perspective, we can also see that the majority of nodes in the system we had were in the emergency state, which is one of the reasons that the motivation system can be very complex. Emergent nodes can add to the complexity level of the system, and they are the main nodes that define systems' irrational type of chaotic behavior. But it's not only these nodes that we have in our system. There are quite a few number of nodes in self-organized stage, which is basically these nodes are the backbone of the network structure. They are autonomous nodes that dictate most of the initial behaviors of the system. Also, they are compared to emergent nodes, they are more established and stable in terms of their behavior. Finally, I divided the whole system into four areas of motivation, demotivation, and destinations with positive utilities and destination with negative utilities to see which metric can better predict the behavior of each of these. As you can see, apart from the motives that mainly be better predicted by the stress centrality or betweenness centrality, the rest of the sections are better predicted by energy centrality, which shows that how important energy centrality can be a system, motivation system like the one that we had. With that, we can come up with some very basic conclusions. The intensity of the motivational force is under the influence of both entropy of the node and the energy of the node. So it's not only one or the other that predicts the intensity of the motivational force. The other very important conclusion, I believe, is that energy is the major predictor of the most of the nodes' utility values. As we just saw in the previous slide, energy can predict most of the motivational and even demotivational forces in case of the destination. Using the approach of this study can enable us to simultaneously consider motivational, demotivational forces together with destinations and have a better estimation of the values. Also, we can study some very interesting approaches of the system, like sub and superlinear growth mechanisms, or, for example, we can identify the positive and negative feedback loops to see why some nodes are in equilibrium stage, others are in aggregation, and others in different stages. Also, we can study some important concepts in the network science, such as resilience, controllability, change, and perturbation, and all of these can be studied following this approach. And with that, thank you for your attention, and I will be happy to answer any questions you might have.